Alright, so here we have an example of an active continental margin. And in this case, you can see that we have a subduction zone. We have the oceanic crust, which is being subducted underneath the continental crust. And the reason that's happening is because the cold oceanic crust has become dense enough that it's actually broken away from the continental crust and is now being pulled towards the mantle. It's now sinking into the mantle. We have very similar features, even though they are different, between passive and active continental margins. You can see that there's still the continental shelf, and that again is still the extension of the continental crust, even though it's underwater. We still have the continental slope, and you can see in this cross section here that little wedge of yellow that is sort of in the middle of the diagram, in between the subducting slab and the continental crust. That little wedge of yellow is again sediment, marine sediment, that is creating that continental slope by filling in all the jagged parts. But then instead of going straight to the abyssal plain, we have an oceanic trench, which is really the main feature of an active continental margin. These trenches create the deepest parts of the ocean. Some of you have probably heard of the deepest trench, the Marianas Trench. It took me a second. It is created by an active subduction zone and an active margin. So even though the actual features, names, aren't that different, what's happening at an active versus passive margin is very different.